this is your review video for Unit 5. Just want to make sure that you chance to hear all of the problems explained here. So first couple should go pretty quickly. Either you know the rational exponent notation or you don't. So here, this is the one that I had said there was a typo on the answer sheet. So if you missed me saying that in class, this one, the base is 11 because that's what's underneath the radical. The index is always the denominator, so this should be to the 5/4 power. So that should be your answer for 1. 2 is just the opposite, go the opposite direction. Bottom is the index, so that's the 4th root of 9 to the 3rd power. You could also write it 4th root of 9 and then with the 3rd power here. Either of those is acceptable. On number 3, this is a jailbreak problem. So I need to break down my 80 to see if it might have 4 of something on the inside. So I did 8 times 10. So 4 times 2. 4 is 2 times 2. And 10 is 2 times 5. So because this is a 4th root, you need groups of 4 in order to escape. So I have a group of 4 2's here. So that means a single 2 gets to come to the outside. Now my 5 is going to be left over. That is going to be stuck underneath. My x's, I do not have 4 x's, so that x is going to be stuck underneath. The y's, so I know that I've got an x underneath as well with my 5. Then on my y's, I do have a group of 4. There are more than 4 y's in y to the 7th, so there's only one group of 4, so that group of 4 bands together and a y gets to come out. When I take out that group of 4 from the 7, there are 3 left. So y cubed is going to be left on the inside. On the z's, I need 4 and I have 4, so that comes out exactly. A z gets to come to the outside. Now I need to write whatever my leftovers were that couldn't escape, so the 5, and then my x y cubed that is stuck on the inside. All right, use the graph of f of x equals 2x squared minus 3 to determine whether the inverse of f of x is a function. So you can use your graphing calculator if you want, but you should know based on parent graphs what this looks like. If these are your axes, it should look something like this. So you're doing the horizontal line test because that is how we determine whether the inverse is a function. And again, that's the key word. If I draw a horizontal line here, it touches twice, so that means no, the inverse is not a function because it fails the horizontal line test. 5 and 6, write the equation of the inverse. On this, the first step is to switch x and y. So x equals 1/2 y plus 6. Now solve for y. So subtract 6. These are not like terms, so that just gives me x minus 6 equals 1/2 y. To get rid of a fraction, I multiply by the reciprocal, so I'm going to multiply both sides by 2. Now over here, that's going to cancel out the 1/2, and y is going to be alone. On this side, do not forget that when you multiply something by a quantity, it has to be distributed. So it's 2 times x and 2 times negative 6. So that should give me 2x minus 12. On 6, same idea, switch my x with my y first. Then I need to get y alone, so subtract the 3. So x minus 3 equals y squared. Now take the square root on both sides, so y equals square root of x minus 3. And that's all that I can do, so I'm going to leave it just like that. Verify that f and g are inverse functions. So we can do that with the composition. We want to show that f of g of x and g of f of x, both of them, simplify down to x. So make sure you show all of your steps here. So f of g of x, that means take this f function, leave a blank parenthesis where the x was. Notice I kept everything else the same, -5, blank parenthesis, plus 3. In the parenthesis goes the inside function, so that's my g, negative 1/5 x plus 3/5. So now I'm going to simplify that. Order of operations. First I'm going to multiply. So negative 5 times negative 1/5 is 1, so that's just 1x, and then that will be negative 5 times 3/5 is negative 3, and then don't forget this plus 3 that you have out here. So then in the next step, the negative 3 and the positive 3 cancel, and I've just got x. So that one worked. Now I do g of f of x, which means I start with this function. So negative 1/5, in place of the x, I put a blank parenthesis, and plus 3/5. I fill in the blank parenthesis with the inside function, which in this case is f of x, so negative 5x plus 3. So first, distribute here. It gives me x minus 3/5 plus 3/5. The 3/5 cancel each other out, and they do both equal x. Change color here so it doesn't run into itself. We do the exact same thing over here. F of g of x, so that means take the f function, leave a blank parenthesis where the x was, and then fill in my g to that blank spot. Order of operations here. First, I can't do what's in the parentheses, so I'm going to go ahead and distribute. 2 times 1/2 is just 1, so I've got x to the 5th. Then I've got 2 times 1/2 is negative 1, and then plus 1. Now, negative 1 plus 1, those cancel, so I've just got 5th root of x to the 5th, which is then x. You have to have all the steps. You can't cross out multiple things in one step. So now g of f of x, I do the same thing. 1/2, where the x was, I leave a blank parenthesis. Then it's 5th power minus 1/2. So in the blank parenthesis goes 5th root of 2x plus 1. So in the parenthesis, I can't do anything. I can't separate the 2x and the 1. So now I take the power. 5th power of a 5th root just cancels out the radical. So I've got just 2x plus 1 there. So now, again, follow order of operations. I have to do the multiplication first. So 1/2 and 2 gives me 1. So then I've got plus 1/2 minus 1/2. So now the 1/2s will cancel, and I just have x, and that is it. All right, 9, 10, and 11. These are your parent graphs. You're describing what all of these number changes do to that graph. So, negatives in front. A negative a means we're going to have a reflection in the x-axis. So I've got that on 9 because of the negative. The 2 means that this is going to be a wider graph. It's going to be stretched from the original, 2 times as wide. Then I've got this plus 3 that's underneath the radical, which means we change the sign and we make it a left 3. That's what I mean by change the sign. If it's positive, you go in the negative direction, which would be left. So that's my answer for 9. On 10, I don't have a negative, so there's no reflection. This 1/4 means that this is going to be a narrower square root graph than the parent graph. This -6, since it's under the radical, that means I go the opposite direction. So a -6 here means I'm going to be moving right 6. This plus 2 is outside the radical, so it keeps its sign. Positive vertical shift means up 2. Here, negative, again, means reflect in the x-axis. The plus 10 means left 10. The -4 means down 4. So 12 and 13, same idea, except now we're actually graphing the changes that we see. So this means I'm going to go left 1 up 2, and those are the only changes. So left 1 up 2, there's my starting point. This is a square root graph, so that means that my next point should go up 1 to the right 1, and the point after that should go from the original, not from the second point, up 2, write 4. And again, remember that you can always plug numbers in here. I know that the square root of 4 comes out evenly, so if you couldn't remember how many to go up or over, just plug in 3 for x and see what you get. Make yourself a t-chart. And it's hard for me to draw on this tablet here, but please make sure that this is curved. It should look like half of a sideways parabola. My domain, my x's, they start at -1 and they get bigger, so greater than or equal to. My range starts at 2 and also gets bigger, so greater than or equal to 2. On 13, this negative means I'm going to reflect it, and then this -2 means right 2. This -3 means down 3. So I'm going to go right 2, down 3 to get my starting point. This is a cube root graph. So this one has the 2 branches. Because it's negative, that means my first branch, I'm going to go down 1, right 1. So my branch is going to go this way. Then you need a branch on the other side. So up 1, left 1. Again, connect the branches separately so that you get the right shape. Some of you have some very crazy looking graphs. On cube roots, remember the domain and range are always all reals. All right, now the equation solving. I've had lots of different types of equations to solve. This first one, I've got a fractional exponent, so that means I need to get the power term alone first. So first thing I do is subtract 5, so I've got 3x equals 192. Oops, 3x to the 3/4, how could I forget that, equals 192. So then divide both sides by 3. I've now got x to the 3/4 equals, and then do the 192 divided by 3 there, which I don't know that one off the top of my head, so I will have to punch it in my calculator. It is 64. So I've got x to the 3/4 equals 64. To undo a 3/4 power, I need the reciprocal power. Again, I am not multiplying both sides by 4/3. I am raising it to the 4/3 power. So those powers cancel each other and x is alone. 64 to the 4/3. If you had this on number 1, you would rewrite it cube root of 64 to the 4th. So cube root of 64 is 4, and then 4 raised to the 4th power gives you 256. So x equals 256. Now you have to check for extraneous solutions, so just double check. If I take the 4th root of 256 to the 3rd power, so 4th root of 256 is 4, to the 3rd power is 64. So 3 times 64 is 192, plus 5 is 197. Make sure you show your check step. My thing isn't very wide here for me to write it down, but you could hear me going through all those steps. So make sure you write down, just like I wrote down right here. Here, if I do this, that writes all of it out. So you're just asking, is this equal to 197? After the first step, if you put it in your calculator to solve the check, that's fine with me. 15. I need to get the radical alone first, just like I got the power alone over here. So first I'm going to add 4 to both sides. So that gives me 3 cube root of x squared plus 9 equals 9. Now, radical still not alone, divide by 3 on both sides first. So cube root of x squared plus 9 equals 3. Now, to take away the cube root, I take the 3rd power on both sides. So on the left side, my radical disappears. On the right side, 3 cubed is 27. So now subtract 9. And I've got x squared equals 18. So take the square root of both sides. It's a plus or minus radical 18, which simplifies to plus or minus 3 radical 2. So now I need to check that. So And I checked it using the radical 18, even though it's not the simplest answer. So when I check, I put in 3 cube root of radical 18 squared plus 9 minus 4, and I'm trying to see if that equals 5. So radical 18 squared is just 18. 18 plus 9 is 27. Cube root of 27 is 3. Times 3 is 9. Minus 4 is 5. So that works. If I plug in the negative version, negative radical 18 squared is also 18, because when you square a negative, it's positive. So you get the exact same thing, which means both of them are solutions. 16, it has double radical. That means you have to get them on opposite sides. So first thing I do is I add this one to the other side. So that gives me 4th root of 3x minus 1 equals 4th root of 2x plus 2. Once they're on opposite sides, then I can take the power. So that just gives me 3x minus 1 equals 2x plus 2. So now it's linear, very easy to solve. So subtract 2x, x minus 1 equals 2. Add 1, x is 3. So then I'm going to check it. So for my check step, I've got 4th root of 3 times 3, which is 9, minus 1, minus 4th root. 2 times 3 is 6, plus 2, and I'm asking, does that equal 0? Well, 9 minus 1 is 8, 6 plus 2 is 8, so 4th root of 8 minus 4th root of 8 is indeed 0. So x equals 3 is a solution. 17, my radical is already alone, so that means I'm going to go ahead and take the appropriate power, which is the second power, on both sides. So I'm going to square both sides. On the left side, that just gets rid of my radical. On the right side, this is a FOIL problem. 4 minus x times 4 minus x. So many of you are just trying to square the front and square the back. You have to FOIL it. So firsts, 4 times 4 is 16. Outsides and insides are both negative 4x. So that gives you negative 8x. And lasts, negative x times negative x is positive x squared. So now I want to solve. So I can't combine any more like terms on individual sides, so I'm going to start moving things over, because if it's quadratic, remember, in order to solve, I need to get everything equal to 0. So I'm going to subtract the 10 on both sides, add the 3x on both sides so that I can get it equal to 0. So x squared didn't have a like term. Negative 8x plus 3x is negative 5x, and 16 minus 10 is 6. So here's my equation. That one is factorable. If I do x minus 3 times x minus 2, I get x equals 3 and x equals 2. Then I need to check both of them. So checking the 3, square root of 10 minus 3 times 3, so that's 9, equals 4 minus 3. 10 minus 9 is 1, square root of 1 is 1. 4 minus 3 is 1. So 3 works. The 2, square root of 10 minus 3 times 2 would be 6, so 10 minus 6 equals 4 minus 2. Square root of 10 minus 6 is square root of 4, which is 2. 4 minus 2 is 2. So both solutions work in that as well. 18, this has addition in it. These are the ones where you have to multiply by the LCD. So I need to find the LCD first. First I do the plain numbers. I've got 2 and 15 and 30. So if I have fractions that have 2, 15, and 30 as the LCD, or as the denominators, my LCD is going to be 30. Then I look and do I see variable factors? I see an x, so that needs included. So 30x is my LCD, so I'm going to multiply the entire equation, both sides, by 30x. When I do that, again, all you're doing with each piece is you're asking yourself, what would I have to multiply this 2 by to get 30x? And hopefully the answer is 15x. So you're going to take that x that you had originally and you're going to multiply it times 15x. And I don't have a lot of room here, so I'm going to write it down here. Then I move on to the next piece. Ask yourself the same question. What did I multiply 15 by to get 30x? Well, I multiplied by 2x, so I'm going to take my 1 and multiply it by 2x as well. What did I multiply 30x by to get 30x? Well, nothing. I multiplied it by 1, so that is just going to stay how it is. So because I multiplied the denominator by 1, I do the same to the numerator, and that is 1 also. So now x times 15x is 15x squared. 1 times 2x is 2x equals 1. It's quadratic, which means I need to get it equal to 0 in order to solve. And now, this one, it is factorable, but it is a split the middle. You're looking for what multiplies to negative 15 and adds to 2. So negative 5, positive 3. So 15x squared minus 5x plus 3x minus 1 equals 0, and then group it. So first group's GCF is 5x, so that gives me 3x minus 1. Second parenthesis has to be the same, which means this needs to be a plus 1 in front. So factorization is 5x plus 1 times 3x minus 1 equals 0. So when I solve this one, I get x equals negative 1/5. When I solve this one, I get x equals 1/3 because you're setting each of those equal to 0. 5x plus 1 equals 0 gives you negative 1/5. 3x minus 1 equals 0 gives you positive 1/3. So now check for the extraneous. On the fraction ones, remember you're not plugging in and seeing if it works. You're just making sure you're not going to get a 0 in the denominator. So if I plug in negative 1/5, 30 times negative 1/5 is negative 6. That's not 0, so it's okay. Here, positive 1/3, 30 times 1/3 is just 10. So both of those, neither of them give me a 0 in the denominator, so I can keep both of them. All right, number 19. Remember that when you have the equations where it's just one fraction on each side, you should solve these ones by cross-multiplying because it makes a proportion. So multiply this times this, so 3x minus 1 times 4x minus 13, and set that equal to 6x minus 2 times 2x plus 5. So now both those sides need FOILed because it's a binomial times a binomial. So 3x times 4x is 12x squared for my firsts. Outsides, 3x times negative 13 there gives me negative 39x. Insides, negative 1 times 4x is negative 4x. And last, negative 1 times negative 13 is positive 13. On the right side, 6x times 2x is 12x squared. Outside, 6x times 5 is 30x. Inside's negative 2 times 2x is negative 4x. Last's negative 2 times 5 is negative 10. So then, this is quadratic. I would simplify the individual sides first. So 12x squared, negative 39 minus 4 is negative 43x. Plus 13 equals 12x squared. Then the 30 minus the 4 is 26x minus 10. Since it's quadratic, I would try to get it equal to 0 by moving my like terms over, but when I try to subtract the 12x over here, it actually cancels on both sides. So now that makes this a linear equation, which means x is on one side, numbers on the other. So subtract the 26x over here. That's going to give you negative 69x on the left. Then subtract the 13 to the other side. That equals negative 23. So to get x alone, you would divide both sides by negative 69. negative 23 divided by negative 69 doesn't come out evenly, but the fraction does reduce. It gives you positive 1/3. So x equals 1/3. Do not forget to check for the extraneous solutions. So I take the 1/3, I check my denominator. 6 times 1/3 is 2. 2 minus 2 would be 0, which means this is extraneous. So this one, because the only solution that I got would give me a 0 in the denominator, this one has no solution. So no solution for this one. 20, perform the operation. This is multiplication, and there's lots of ways you can do this. Since the numbers are small, I would just multiply straight across. 2 times 25 is 50, x, y squared. On the bottom, 5 times 10, also 50, y. So now when I go to reduce it, the 50 and the 50 cancel. I subtract the exponents on the y, so 2 minus 1 is 1. So that just gives me xy. Over here, this is division, so I'm going to change that to multiplication by the reciprocal. So m to the 4th over k to the 7th. Scratch that out so I don't get visually confused. So now multiply across, so that's going to give me 3 k to the 4th, m to the 4th, over 6 m k to the 7th. So now, the 3 and the 6, I do that first. They're both divisible by 3, so that leaves me with a 2 in the bottom. The k's, 7 minus 4 is 3, so there's 3 k's left in the bottom. And the m's, I've got a 4 here and a 1 here. 4 minus 1 is 3, so m cubed on top. So m cubed over 2k cubed. 22, I've got multiplication. I need to factor these. The left side, top doesn't factor and bottom is already factored. But the right side, that needs factored. So I'm going to recopy the left side. It's already as simplified as I can get it. But the right side, I need to write it in factored form. That top is x plus 3 times x plus 1. The bottom, 4x squared minus 9, that's a difference of squares. So 2x plus 3 times 2x minus 3. So now, when we have multiplication here, we can cross-cancel like factors. So 2x minus 3, those cancel. X plus 3, this cancels with one of these. There were 2, so there's still 1 left. So now, top times top, nothing. So 1 times this is x plus 1 on the top. On the bottom, I've got x plus 3 times 2x plus 3. And you do not have to FOIL those out. Leave those in factored form. So that is my answer. 23, same thing. I need to factor this first. So this first one factors into x plus 10 times x minus 2. On the bottom, there's a GCF of 5x squared, which leaves me with x plus 10. This is division. So when I factor it, I'm going to go ahead and flip it as well. So this bottom is going to become the top over here. And x squared plus 7x minus 18 is going to factor into x plus 9 times x minus 2. This guy has a GCF of x and x plus 9. So I'm going to scratch this out because I already wrote multiplication by the reciprocal. So now I'm going to cancel my common factors. So I've got x plus 10s above each other here. I've got x plus 9s that cancel in this fraction. And on this one, I actually don't have anything that cross reduces from here to here or here to here. So go ahead and multiply across. X minus 2 times x minus 2 is x minus 2 squared. And on the bottom, 5x squared times x is 5x cubed. And nothing else on the bottom. So this is my final answer. 24. This is addition and subtraction. To add and subtract fractions, you have to have a common denominator. And to find an LCD, you have to have it in factored form. So I have to factor this first one. The other two are already factored. So my LCD, the two factors that I see are x minus 3 and x plus 3. So that is my LCD. So after I determine my LCD, my next step is to convert the fractions. So all I'm doing is asking myself, what would I multiply this original denominator by to get my LCD? And on the first one, I would just multiply it by 1. It doesn't change. So that means the numerator also doesn't change. Second fraction, in order to get x minus 3 and x plus 3 on the bottom, I would have to multiply the bottom by x minus 3. So I need to do the same thing on the top. Remember, that means distribute 2 times x and 2 times negative 3. So 2x minus 6. Third fraction, x minus 3 times x plus 3. So I had to multiply the bottom by x plus 3, so do the same on the top. Again, remembering to distribute. 2 times x is 2x, 2 times 3 is 6. So now I can make it one fraction with the LCD on the bottom, and I can just do the addition subtraction. So 4x plus 2x minus 6. This is subtraction. Remember, distribute the negative. So minus 2x minus 6. So now combine my like terms. 2x and negative 2x cancel. So I've got 4x minus 12 over my x minus 3x plus 3. Then that top factors, GCF of 4. And when I take the GCF out, then I have a common factor. The x minus 3's cancel. So I'm left with a 4 in the numerator and x plus 3 in the denominator. All right, 25. Complex fractions on both 25 and 26. Remember that the steps here are to completely simplify numerators and denominators first. So in order to simplify this numerator, I need an LCD. So the common denominator is 2x. To get to the common denominator, I would multiply the bottom by 2, which means I do the same to the top. So 2 times 2 is 4. Here, this had the LCD, so I don't change the numerator either. So 4 minus 1 is 3. So the top simplifies to 3 over 2x. The bottom, the LCD there, should be 12x. I need the first number that is divisible by both 3 and 4, and because there's an x, I need that in my LCD. So here I would have multiplied the bottom by 4, so I multiply the top by 4 as well. 4 times 1 is 4. Here, bottom by 3, so top by 3 as well. 3 times 3 is 9, and 4 plus 9 is 13, so 13 over 12x. Once you've simplified the top and simplified the bottom, now you're going to rewrite the complex fraction as a division problem. This, 3 over 2x, divided by the bottom, 13 over 12x. Division problems change to multiplication by the reciprocal, so 12x over 13. So the 2 goes into the 12 6 times. X's cancel. So on top, 3 times 6 is 18. On bottom, these both canceled, so 1 times 13 is 13. And that is it. Last one. So completely simplify the numerator first, so I need to factor that numerator. So that's x plus 8 squared over negative 42x. Nothing else I can do with that. Denominator, x plus 8 over negative 7x. There's nothing else that I can do with that. So here, one step of factoring was the only simplification I needed in that numerator. So now turn the fraction into a division problem, x plus 8 squared over negative 42x multiplied by the reciprocal, so negative 7x over x plus 8. So I can cross cancel one of the x plus 8's here with this one. The x's cancel. And negative 42 and negative 7, both divisible by negative 7, so that Negative 7 divided by negative 7 is 1. Negative 4 divided by negative 7 is positive 6. So on the top, I've got x plus 8 times 1, which is x plus 8. And on the bottom, I have a 6. And that is it. All right. Hopefully the explanation of those problems helps you remember some of the steps. Remember that there are 2 quiz review videos as well as the individual lesson videos if you need some additional review. That is it for this one. And I was supposed to give a shout out to Davion, so here's your shout out.